Welcome to Ask and Learn.
In this problem, we have a beam here that is pinned at the left side and is being lifted by a motor and a cable running over a pulley. Um, the beam makes an angle theta with the horizontal, and this angle here, the cable makes an angle phi with the horizontal. And so the direction of this one is known. So we have our reaction at the pin joint, and we're going to call this the origin. F3 here is the weight of the beam, which acts at the center of the beam. And then here we have the force in the cable in this direction, given by this vector here, with this magnitude. And then we know that R2 is actually just is twice R3. So it's just L times this unit vector. And so then we have everything we need to sum our forces and moments and set them equal to 0. And we'll get 3 equations for our 3 unknowns here. And generally in terms of the weight and the angles, we have F1x is given by this expression. F1y by this expression, and the tension in the cable by this expression. Now you can see a couple things here to check to make sure that these make sense. Number one, all of these scale linearly with the weight, which makes sense. And we can also see that if theta equals phi, then this is 0, and then sine of 0 is 0, and then we get infinite load here. And that's because basically we're trying to, if our cable was coaxial with the beam, then there'd be nothing to counteract the moment of the weight here. So everything would have to blow up, and we wouldn't basically be able to have an equilibrium. So we always need, in fact, in our cases here, we're going to have that phi will be greater than theta. So this thing is actually going to be negative, which means that this negative sign, if we plugged in numbers here, this would actually be positive, which we'd expect, right? We'd expect that tension to be in that direction. What else can we say? Let's see here. Yeah, I guess if we look at this, if theta is 0, then this just becomes 1, and this becomes minus phi. And so, say if theta is phi is 90 degrees, then this winds up being W over 2. So again, we are pulling with half the weight over here. If we were pulling, if the beam were horizontal and we were pulling strictly vertical. So when you do things symbolically like this, you can do some checks to make sure things seem okay. And likewise, if we set this to 0 and this to 0 and phi to 0, then this goes away. So that makes sense because our load is vertical, and then there should be no horizontal load here. And over here, let's see what happens here. If we set this to 0, this to 0, and this to 90, so this we get 1 over minus, so we get, yeah, so this winds up being 3 minus 1, so we get 2, and we get W over 2. So again, that makes sense. So we can do some checks to make sure that some limiting cases to make sure that things work. The other case is that if you look, say if phi is less than theta, then this is positive, and this means that's negative. And basically what that means is that if the beam, we can't really lift the beam higher, greater than this angle, because then the cable would be in compression. So if we have we need something that could withstand compression to be able to have a phi that is less than theta.